In this video, we are going to look at a problem that involves the combined gas law. So the problem said the gas that fills 5.6 liters is initially at 23 degrees Celsius and 2.3 atm. So these are our initial values. So 23 degrees Celsius, that would be a temperature, an initial temperature, so a T1, and 2.3 atms, that's a pressure, and its initial pressure, so P1. The gas is heated. The final temperature is 78.0 degrees Celsius, that's our T2 value, and the final pressure is 3.2 atm, so that would be our P2 value, our final pressure. Okay, and it says what is the final volume of the gas? So we know that what we're looking for is our V2 value. So this must be our V1 value, it's our initial volume. So we have all these different variables, V1, T1, P1, P2, and V2. And our combined gas law says that PV over T, P1, V1 over T1, equals P2, V2 over T2. And so we just need to substitute in our variables and solve for the variable that we're looking for, which is V2. We're looking for V2. Okay, so let's go ahead and substitute in some variables, and while we're doing this we need to pay attention to our units. Our units of pressure need to be the same for both of our values. Our P1 is an atm and our P2 is also an atm, so those are good. Our temperature, our T1 and T2 are both currently in Celsius, but we need those to be in Kelvin. So before we plug them in, we'll go ahead and convert those to Kelvin. So let's do that real quick. T1, T2. T1 is 23, and of course we add 273 to convert Celsius to Kelvin. 23 plus 273 gives us 296 for T1, and then 78 plus 273 gives us 351 for T2. So now that we have those converted to Kelvin, we checked our units of pressure to make sure they were the same, and our units of volume are in liters, so our V2 value will also come out in liters. So some number of liters will be our answer for our V2 value. So now let's substitute in some numbers. P1 is 2.3 atm, and V1 is 5.60 liters over T1, which we said is 296 Kelvin, and that all equals P2, which we said is 3.2 atm, times our V2, which we don't have, so that'll be our value of X, divided by T2, which is 351 Kelvin. Okay, so we have our problem all set up. So now let's go ahead and do a little bit of simplification. I'm going to go ahead and cross multiply. So 2.3 times 5.6 times 351. 2.3 times 5.6 times 351 will all equal 296 times 3.2 times X. Sorry, I made a mistake there. 296 times 3.2 times X. And if you might notice, I'm leaving off all my units now to make it a little bit easier to look at the algebra. So let's do this math in our calculator. Let's see. 2.3 times 5.6 times 351 gives us 4520.88. And I'm not rounding this value at all because this is an intermediate value. So I'm keeping this entire value down here equals 296 times 3.2 times X, so 947.2X. Okay, alright, and then all I have left, whoop, that got erased a little bit. All that I have left is I need to isolate X. X is currently being multiplied by the 947.2, so I'm going to divide by 947.2. And if I do that on one side, I also do that on the other side of my equation. So now I'm going to be left, and I'm putting it up here, with x equals whatever this is, 4520.88 divided by 947.2, and I got this value right here, 4.77289. I'm going to go ahead and hold out that many decimal places so when I round, I can round effectively. So my x, of course, is equal to my V2 value, which we said would come out in liters. And so all we need to do is round to correct significant figures. Looking back at our problem, we have 3, 3, 3, and 3, and 3 significant figures. So we're going to round to 3 for our final answer. Looking at that 2, the 7 isn't going to round up, it's going to stay a 7. So 4.77 liters is our final volume.